Hello everybody, this is the Problem of the Week solution video for May 28th, 2021's Problem of the Week Warehouse. The problem description goes as follows. Elvira is processing shipments for the Christmas season. There are various shipments of toys coming into her warehouse throughout the day, and her boss wants a summary report at the end. Each shipment consists of some number of a single kind of toy. The summary report is an aggregated list of all the toys that arrived at the warehouse over the day. The boss is most interested in the biggest sellers, so the toys should be sorted in decreasing order of count. If the warehouse received the same number of two kinds of toys, sort them in alphabetical order, and there's a footnote at the bottom, I'll read that shortly. As for our input, the first line of input contains the number of test cases where 1 is less than or equal to t is less than or equal to 100, and each test case begins with a line containing an integer, n, such that 1 is less than or equal to n is less than or equal to 100. This indicates that n shipments are coming in for processing. Each of the next n lines describes a single shipment. The line contains a string and an integer, the name of the toy, and how many of the toy are in the given shipment. The name of the toy is a string of at most 10 lowercase characters, A through Z, and between 1 and 10 toys arrive in a given shipment. For our output, for each test case, output k, the number of unique toys that have arrived in the warehouse. Then output k lines, each containing the name of the toy and how many of that toy have arrived, summed up over all the shipments. Output toys in decreasing order of count, breaking ties alphabetically. And our footnote from before, to determine which of two strings comes first in alphabetical order, their first letters are compared. If they differ, then the string whose first letter comes earlier in the alphabet comes before the other string. If the first letters are the same, then the second letters are compared, and so on. If a position is reached where one string has no more letters to compare while the other does, then the shorter string is deemed to come first in alphabetical order. Alright, so it seems that this is a job for the dictionary type in Python, and we're going to have to use a lot of sorting functions in order to put the items into an order that is satisfactory. We'll have to make sure that the item values for each item stay with that item for the entire time in order to have an accurate recording. So let's now go to the sample solution. The first thing that we do in the first 5 lines is to gather how many test cases we have and set up a loop for that many test cases. Next, we see how many items are going to be in that test case and declare a dictionary used to store our key value pairs of items and quantity of items. The for loops beginning in line 8 iterates through however many items are in that test case. Using the split function, we split our one line of input into the name of the item and the number, because of the input formatting that's given in the description. In our next block of code, we basically seek to merge the values of each line of code by the name of the item. If we have two items with the same name, we want to combine the values of them and just keep that value. In this block, if the name of the item is not found within the keys of our dictionary, we'll just initialize the value to the count that was given. If it is found within the dictionary, we'll increment the existing value by the count that we get. Note that every single time we interact with the variable count, it's casted from a string into an integer, which is what is resultant from our input.split function, because we want to work with numbers in this scenario rather than the string. The next step that we have is to work on sorting the items. If you recall from the description, we have to end up with the toys in a decreasing order of count, with ties being broken alphabetically. With the sorting functionality in the standard library of Python, that means that we'll have to sort it alphabetically first, thereby breaking all the ties in the first stage, and then we'll have to rearrange it in descending order by count after that. So that's exactly what we do in lines 17 and 18. In line 17, we use the sorted function to sort it alphabetically, which takes in the parameter of what we sort and then an optional key parameter that the sort function will sort by. The dictionary type has the items method, which returns basically a 2D array containing the key and value pairs within the dictionary. In the key position, we're feeding it the 0th index of this item, which is the key or the name of the toy. Notice the syntax of lambda item colon item 0. In Python, lambdas are what you call anonymous functions, meaning that we can inline it within a function to pass through an item that is changing every single time. Essentially, because the key is changing every time a new item or a new key value pair is being parsed by the sorted function, instead of passing through a fixed key, we must pass through something that tells the function how to get to the key. This allows us to create a shortcut essentially in order to feed the key of the dictionary such that it can be sorted. One final thing that we have to do is to cast it back into a dictionary. During the sorting process, we've essentially broken down our inventory variable into that 2D array we were mentioning, so we'll turn it back into a dictionary there. The same thing is done here in line 18, but instead of having our lambda return the 0th index of the item, we'll ask for the index number 1, which corresponds to the integer value that we found in the count. We'll also tack on this parameter reverse equals true because we want to sort it by decreasing order. Alright, so now that all of our data is sorted out, we just have to format it in the way that they asked for. Line 21 prints out the number of unique items based on the number of key value pairs within our inventory variable, and the rest of the program just prints out the rest of it sorted accordingly. So we just have a for loop and then print out our I, which is the iterating variable, and then we print out the value that corresponds to that. So that's it for the code, and let's try out our sample test case. Our value of t is 2, and the first test case value of n is 4, where Furby 4, Elmo 5, Furby 1, Kirby 10, sorry, can't type, should return 3 Kirby 10, Elmo 5, Furby 5. Alright, and our second and final test case value of n is 2, and the value of that is fun game 1, fun 1, and that should return 2 fun 1, fun game 1. Alright, so I believe this concludes this problem of the week solution video. I hope that you've enjoyed these, as it has been a real joy being part of this for me. Anyways, have a great summer everyone, and I hope to see you around.